Hi everyone, welcome to the lecture on Fourier series. As you know, in the previous video, we have discussed the many example and important concept of Fourier series. If you have not seen that lecture, then link is given in the description box. Also at the end of this video, you will get the link of that video. Must watch that video so that you will get a clear idea of what is a Fourier series, how to check even, odd and how to solve the question. Now, today we are discussing this example. Find the Fourier series for the periodic function. Here, when we discuss the Fourier series, so always our function is periodic function, and for periodic function we are applying the Fourier series. So here specially they have mentioned that our function is periodic function defined by f of x is 0 in the interval minus pi to 0 and it is x in the interval 0 to pi. Hence, show that pi square by 8 is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square and so on. So after getting Fourier series, we have to prove the additional part. So firstly, see here our function is given break in two parts. So it is a minus pi to pi, interval is our minus pi to pi, and function is minus pi to 0, it is 0, and 0 to pi function is x. Now when we have given the integration limit is minus a to a, that time we always use the concept of even and odd function. But when that function is x square, x cube, x sine, cos, or sometimes there is a product of term, addition of the term, so that time we can use that even and odd term when that function is divided in this way in two parts. So again we can check even and odd, but उसमें क्या होता है, here value of given function is defined as x in the interval 0 to pi. तो सेम यहाँ पे भी होना चाहिए था with minus sign, that means here it is a minus x. So function अगर two parts में break है तो वो term जिस तरह से define किया है that should be same, only change in the minus sign. So if it is a plus x, then here minus x plus x square minus x square, that time again you can use the even and odd concept. But here our function is neither even nor odd function. So in short, for the Fourier series, we have to find all three constants, because we know that if our function is even, so only need to find a0 and an. If our function is odd, then only need to find the bn. तो हमारा overall calculation part बच जाता है अगर हमारा function even या odd category में belong करता है तो. But here this function is neither even nor odd. That means you have to find all three constants a0, an, bn. So see here how to solve this question. Firstly, I will write here general formula of Fourier series. So here the formula of Fourier series of function f of x is a0 by 2 plus summation n varies from 1 to infinity an cos nx, when interval is minus pi to pi, then it is a cos nx, plus bn sin nx, and this Fourier series I will consider equation 1. So जैसे हमें find out करना था that Fourier series is this one. So for Fourier series we require to find this a0, an, bn, this three constant, and to find a0 formula is 1 upon pi integral minus pi to pi, as per the given interval is minus pi to pi. So we have to take integral limit is minus pi to pi f of x dx. Now in the next step, put the value of function, but here our function is break in two parts. So here integration also you have to break. So I will write here integral first minus pi to 0 f of x dx plus 0 to pi f of x dx. Now if we put the value of function here, so in minus pi to 0 function is 0 and here it is a x. So this term is 0, integration of 0 is 0, so no need to write the 0. So here remaining is 1 upon pi outside constant and this integral 0 to pi x dx. So जो term 0 है वहाँ पे 0 लिख के then आप उसको 0 करके हटा सकते हो. Otherwise you can directly write this term is a 0, so no need to write here 0. Immediately you just non-zero term you can mention, so it is a x. Now take the integration of x. So integration of x is x square by 2, limit is 0 to pi. Put upper limit minus of lower limit. Upper limit is pi, So outside 1 upon pi as it is, and if you put upper limit, pi square and this constant 2 minus of lower limit 0. So here this pi get cancelled. So the final answer, that is a value of a naught, is pi by 2. So hence we get the first constant answer pi by 2. Similarly, we have to find the next constant, that is an. So here the formula of finding an is 1 upon pi integral minus pi to pi f of x. In all three integration there is a f of x function into here multiplication of an is cos. So here we have to take cos nx. That here an multiplication cos, that's why you have to write f of x cos nx. यहाँ पे a नॉट के मल्टीप्लिकेशन में कुछ भी नहीं था, तो सिंपली यू हैव टू टेक f of x. तो ये सारी ट्रिक है फॉर्मूलेस को याद रखने के लिए, ताकि समटाइम्स कंफ्यूजन होगा कि साइन लेना है कि कॉस लेना है an में, तो आप इस तरह से याद रख सकते हो कि ओके an into cos है, so you take the cos. Now again here also you have to put the value of function, but function is divided into two parts, so we have to write the integral minus pi to 0 f of x cos nx dx plus next is 0 to pi f of x cos nx dx. Now here in this interval value of function is 0 and here it is a x. So again no need to write the 0 term, so I will write only the second integral 0 to pi x cos nx dx. Now to solve this integral we have to use the integration by parts formula, but integration by parts formula use करते वक्त थोड़ा सा क्वेश्चन लेंदी लग सकता है, so better way you have to use the continuous integration by parts formula that we have already discussed in the integration chapter, multiple integration, Laplace, again we have discussed that type of integral, and here again I will explain how to use the continuous integration formula. So keep this formula in your mind and always remember that formula, because in Fourier series many times we are using this integration by parts formula. So see here, integration of u v dx, when it is an integration of product of two terms, so write down u as it is. The same rule you have to apply u in integration by parts formula. So u as it is, integration of second term, so second term, so I will denote is by dash. So this dash is denoting integration of v. First term as it is, integration of second term. So when you write this first term correctly, so remaining term you will get automatically. So here alternate plus minus, they take the continuous derivative of first term and integration of second term. So derivative of u is u1, integration of v is second integral, so I will write it is v2, then plus u2 v3 minus u3 v4 and so on. So in this formula you have to take the derivative of first term and integration of second term continuously with alternate plus minus and so on. So you see here it is contain power of x simply 1, but sometimes there is a power of x is 3, 4, 5. So integration by parts will be difficult to use, that's why you have to use this continuous integral formula. So if I will apply this formula, so a0, so here 1 upon pi constant as it is, u as it is, x is our u, so first is u as it is, integration of second term, so integration of cos is sine nx upon n. So integration of cos is sine nx upon n, then alternate plus minus, so minus derivative of first term, so derivative of x is 1, integration of this second term, so integration of sine is minus cos nx upon n, and already is there n, because जो v1 आपको मिला है उसी का आपको सेकेंड इंटीग्रल निकालना है, तो v1 is our sin nx upon n है, so इसी टर्म को अगेन इंटीग्रेट, तो there is already n, और sin integration is minus cos nx upon n, so there is n square. Next take the derivative of 1, so first term का derivative, x का derivative 1, derivative of 1 is 0, so next term, all remaining next term will be 0. Integral limit is 0 to pi. Now put upper limit minus of lower limit, So when we put upper limit here, so sine n pi is 0. So sine n pi is 0, as well as when we put lower limit, so sine of 0 is also 0. So that means for upper as well as lower limit, sine term is 0. Put upper limit, lower limit in the next term. So a0, it is a an, sorry, it is a an. So here sine n pi and sine 0 is 0. So for upper as well as lower limit, this first term is 0. So only you have to put upper limit, lower limit in this second term. And here minus of minus is plus. This n square is also constant. You can take outside also. So here 1 upon pi I will write as it is. This first term is 0. And this minus of minus plus. Upper limit if we put here, so it become a cos n pi upon n square, minus of lower limit, so it is cos of 0 is 1 upon n square as it is. So you can take constant outside or then put the upper limit, lower limit, that is again okay. Otherwise put the upper limit, lower limit, then you can take the n square outside common. So here 1 upon n square pi, this n square if we take common, so it is 1 upon n square pi cos n pi, value of cos n pi is minus 1 raised to the power n. So this is a minus 1 raised to the power n minus 1. Hence we get the a n. So for Fourier series, हमने a0 and an दोनों values को find out किए. So now the last constant is remain, that is a bn. So formula of finding bn is bn 1 upon pi integral minus pi to pi f of x. Now see here in the formula bn into sine, so here we have to take sine n x dx. Now again put the value of function. So function is again break in two parts, so that's why we have to write here bn 1 upon pi constant outside as it is. Here it is minus pi to 0 f of x into sine nx dx plus 0 to pi f of x sine nx dx. Now see here 0 to minus pi to 0, value of function is 0. So this is integral is 0, and in second integral here we have to put x. So therefore our bn is 1 upon pi constant outside integral 0 to pi, it is x into sine nx dx. Again there is a product term, so you have to use the integration by parts formula, or same formula you have to apply here in continuous integration by parts formula. So this is our u and this term is v. So u as it is integration of v. So using that term here x as it is integration of v. So integration of sine is minus cos nx upon n. Alternate plus minus, so minus derivative of first term, so derivative of x is 1 and integration of this bracket term, so second term integral is this one, and again take this integral. So integration of cos is sine nx upon n, and here there is already minus sign, so we can write integration of cos is sine nx upon n, and here n is there already, so it becomes an n square. Limit is 0 to pi. Now put upper limit minus of lower limit, and as you know that for upper as well as lower, sine is 0. Sine n pi is 0 and sine of 0 is 0. So both term is 0. That's why here this term is 0 for upper as well as lower limit. That means completely is 0. Now put upper limit here. So x equal to pi if we put, so it is a minus, this minus sign is there, minus pi cos n pi divided by n. Minus of lower limit. Lower limit is 0. So if we put here x equals to 0, so 0 into this term, so cos of 0 is 1, but x is 0. So 0 into this term, so that means this whole term is 0. So here for lower limit, this second term is, if we simplify this term, so this outside pi and this pi get cancelled. Remaining is minus 1 upon n cos n pi. So here in the next step, we will get minus cos n pi upon n. And cos we can write in the form of minus. So cos n pi is minus 1 raised to the power n upon n. Now here minus and minus both are in product form. So it is a n times minus. So minus 1 raised to the power n and this minus. So that means total minus is minus 1 raised to the power n plus 1. So it is actually product of minus 1 minus 1. So so here our Bn is minus 1 raised to the power n plus 1 upon n. So this is the value of Bn. So I will write here our Bn is minus 1 raised to the power n upon n. So all three constants are known. So put this three constant a0, a and bn in this formula of Fourier series. That is our question, find Fourier series. So put this value in equation 1, a0, a and bn. So therefore f of x is a0 by 2. a0 is pi by 2 by 2. So by 2 that means this term is in multiplication. So either you can write directly pi by 4 or put the value. So a0 by 2, so it is a a0 divided by 2 plus of summation n varies from 1 to infinity an is minus 1 raised to the power n minus 1 upon n square pi into cos nx plus bn is minus 1 raised to the power n by n into sine nx. Now here this is nothing but our pi by 4. So our f of x is pi by 4 plus summation minus 1 raised to the power n minus 1 upon n square pi into cos nx plus minus 1 raised to the power n upon n sine nx. So hence we get the Fourier series. So this is our required answer, Fourier series corresponding to our function. Now in addition here we have to also show that this pi square by 8 equal to this series. अब इस series को अगर observe करते तो it contain completely odd numbers 1, 3, 5, next term will be 7. अब ये किस तरह से मिलेगा देखो here if you observe this term, so sin यहाँ पे पूरे term में n 1, 2, 3, 4 every term के लिए ये exist करेगा. But when we put here n is 1, so यहाँ पे n is 1 तो it is a 1 upon 1 square pi. अगर n 2 put करते हैं तो ये n is 2, that means here summation is varies from n 1 to infinity. तो n is 2 तो minus 1 power is 2, that is 1, and 1 minus 1 is 0. So for every even number it gives the answer 0. So this term is 0 for, this term is completely 0 for n is even. And if for even term is 0, that means it is exist only for odd numbers. So you will get this type of series. So इसमें सिर्फ sign is creating the problem. So for to make this term 0, so you can put x equals to 0. So ये एक तरीका है put the value of x to find this additional part. अब इसके लिए x को put up करना है तो क्या put करेंगे, तो ये 0 कब होगा, when sin of 0 is 0, sin pi is also 0. अब यहाँ पे sin pi अगर पुट अप करते हैं तो ये फंक्शन x इक्वल्स टू पाई के ऊपर करस्पॉन्डिंग वैल्यू आपको मिलेगी. बट हियर sin pi is 0 बट cos of pi, तो cos n pi you will get a minus 1 raised to the power n. So it create some complicated. तो इस टाइप के क्वेश्चन when you will doing the practice of same type of question, so you will get idea कि which value of x you have to put. So I will put here x equals to 0 and here our function is continuous at point 0. तो यहाँ पे 0 पे discontinuity नहीं है. Otherwise you have to use the Dirichlet condition if it is having the discontinuity at 0. So अगर इसको discontinuity होती है तो then you have to use the Dirichlet condition, and that Dirichlet condition also we have discussed in the previous video. That link is given in the description box. You can check the playlist of Fourier series. In that playlist you can find the Dirichlet condition. So this function left hand limit and right hand limit is 0, so limit is exist, and as well as value of function at 0 is 0, so this function is continuous at 0. So therefore function at f of 0 if we put x equals to 0, so our function f of 0 is 0. So put x equals to 0 in this Fourier series, and f of 0 is known because when we put x equal to 0, so x equals to 0, here you will get a 0 answer. So here left hand side of this Fourier series is 0 because when we put x is 0, so this term is 0. Right hand side is pi by 4 plus summation n varies from 1 to infinity. Here minus 1 raised to the power n minus 1 divided by n square pi. Cos of 0 is 1 and sine of 0 is 0. Now here expand this summation. So if we put n is 1, 2, 3, 4, and we know that for every even n it becomes a 0. So I will here shift this pi by 4 in left hand side. So it is a minus pi by 4 equal to n is 1. So it is a, for odd number this now become a minus 2. So for every odd number this numerator become minus 2. तो ये भी याद रखो बिकॉज अगर थोड़ी थोड़ी चीजें आप ओरली करते हो तो प्रॉब्लम थोड़ा सिंपल हो जाता है. तो n के वैल्यू ऑड है तो ये होगा माइनस माइनस. सो माइनस वन बिकम माइनस 2. तो हर एक ऑड नंबर के लिए यहाँ पे माइनस 2 आएगा. सो माइनस 2 अपॉन n इज 1. सो 1 स्क्वायर pi. नेक्स्ट टर्म n is 2. So for 2 it is 0. n is 3. So for 3 it is numerator is always minus 2, and here for 3 it is 3 square by pi. n is 3, so it is 3 square by pi. n is 4, 0. n is 5, so it become minus 2 upon 5 square pi, and so on. Now here minus 2, minus 2, minus 2. Just take the common, and minus 2 by pi you can shift in left hand side. So firstly I will take this minus 2 by pi common. So remaining term is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square. If we continue this term, so you will get next is 1 upon 7 square, and so on. Now shift this term. So division term shifting will be multiply, and this multiplication to shifting will be divide. So this minus term we are shifting in left hand side. So this minus also get cancelled. So pi square by 8 is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, and so on up to the infinity. So hence we get the answer of our question. So in this way you have to solve the Fourier series question. In the next video we will discuss the more interesting and important questions. So to get the notification of that video, you must have to subscribe my channel, click on the bell icon so that you will get a notification of that video. Also share this video with your maximum friends so that they will also get the benefit of this video. Thank you for